Alright, so I know you guys should be pretty familiar with projectile motion already, but just to reiterate the basic concepts. So the definition of a projectile motion is the first one, the object leaves support with initial speed, so there should be an initial velocity. And also only gravity is affecting the object during the flight time. So it's a constant acceleration, and the acceleration will be negative 9.8 meters per second squared. So because it's a constant acceleration motion, we can use those equations to describe and calculate the variables you want to know the motion or to describe the motion. Alright, so and those complicated equations you saw in previous video are all derived from these basic constant acceleration equations. So I'll walk you go through that process later. So those are important definition of a projectile motion. And actually there are two types of projectile motion, which are described by these two graphs. And can you see the difference between those? So actually they are just with or without projection height. They are all projectile motion. They leave support with initial velocity, and there is no external force except for gravity. So those are projectile motion, but with or without projection height will make the equation different, or without projection height, the equation will be a little bit less complicated. So for example, take a flight. When we talk about flight time, if there is projection height, you need an h here, so the equation looks like this. But if projection height equals to 0, the equation looks a lot more simpler, right? But actually they are the same equations. If you put 0 here, you'll remove this whole thing, and this square will come out of the square root. So those equations are basically the same, but if you know the projection height is 0, you can make the equation a lot more simpler. So just make sure you understand the motion and think about which type is it when you're using the equation. That'll save you some time. Alright, so there are 3 numbers we need from projectile motion, and those 3 numbers can give you everything you need to describe the whole motion of the object. So the 3 variables are initial velocity, projection angle, and projection height. And how do we get those parameters on Dartfish? We can talk about projection angle and height first. So projection angle, there is a goniometer on the screen, so we can just directly measure it. And also the projection height is the distance between the height of ball release to the ground. And actually you've already got those numbers, so you can see the angle of projection of the ball, 57.3 is here, 57.3. And also projection height, 1.04 meters, 1.04 meters. So you just gotta understand how we get those from Dartfish, and you've already got those numbers on your manual. So that's about these 2 parameters, but how about initial velocity? That's a little bit indirect. So we know velocity, you need distance divided by time to get it, right? So this is how we calculate velocity on Dartfish. So say we take a screenshot when the ball, at the instant when the ball leaves the foot. So that's here, right? And we record the time point, which is 0.799. And we put this number here. So that's the clip time at moment of ball release. And then we advance 1 frame. So we change 1 instant, and we record the time point of that frame, and also the displacement between these 2 frames of the ball. Right. So for example, you got the time clip for second frame is 0.866. Time point for clip 1 will be 0.799. So the change between 2 time points will be the change of time. And also change in position between frames will be the displacement of the ball between these 2 frames. So you got a displacement divided by time, which is 0.59 here, divide by the difference between these two time points, which is 0.866 minus 0.799. So that's how you're going to use those numbers to calculate the initial velocity of the ball. So change in time between frames, delta t, would be 0.866 minus 0.799. So you put this thing here, and you put the result here. So that's how you complete the table. And this is how we measure the velocity on dartfish. Alright, so with those three numbers, we're going to calculate these three variables for each exercise, which are time of flight, the range, and maximum height. And we're going to use these equations, and I know those equations looks pretty disgusting. And before you throw up, we'll just proceed to next video, and I'll explain through how we get those equations. So you know, those questions are pretty similar in each exercise. You gotta get a horizontal and vertical component of initial velocity, and use the equation to calculate time of flight with this one, range with this one, and also maximum height with this equation. So that's about it, lab activity, and I'll explain the equations in next video.